Welcome to our channel. Parallel universes may exist, and the evidence is closer than you think. The multiverse, evidence we might not be alone in existent silence. A single point of light. And then, imagine staring into the deepest darkness the cosmos has to offer, only to find something that should not exist. A circular scar imprinted on the oldest light in the universe, as if our entire reality had collided with something vast, ancient, and completely beyond comprehension. A cosmic bruise. A fingerprint from another universe. For decades, physicists believed our cosmos was the entirety of existence, all of space, time, energy, and matter contained within one grand structure. One universe. Singular. Absolute. But the growing weight of evidence suggests something astonishing. The universe might not be alone. What if the Big Bang was not the beginning, but simply one event in an infinite cosmic landscape? What if our universe is one bubble in a foaming sea of universes? What if reality branches into new paths every time a particle is measured, creating endless parallel timelines? And what if the cold scars, strange flows, and quantum shadows we now detect are hints from neighbors we were never meant to know existed? Tonight, we journey to the edges of physics, cosmology, and human understanding as we explore the groundbreaking possibility that we are surrounded by, and perhaps shaped by, a multiverse. Prepare yourselves. The story begins. In 1929, Edwin Hubble looked into the night sky and discovered something that shattered astronomy. Every galaxy, everywhere he looked, was moving away from us. The universe wasn't static, it was expanding. This discovery implied something radical. If everything is moving outward today, then at some point in the past, everything must have been unimaginably compressed. Hot, dense, unified. This was the birth of the Big Bang model, the moment everything began. But soon, physicists realized the Big Bang came with contradictions. Deep, troubling contradictions. 3 problems in particular hinted at something bigger than the universe itself. The first was the horizon paradox. Opposite sides of the universe, separated by vast distances, have the exact same temperature, down to 1 part in 100,000. There is no known way for light or energy to have traveled fast enough between these regions to equalize them. They should look different. But they don't. The second was the flatness problem. The universe is astonishingly flat, not curved inward like a sphere, not curved outward like a saddle. Perfectly balanced. Too perfectly. Like a pencil standing upright on its point, never falling. And the third puzzle, magnetic monopoles, exotic relics from the early universe predicted by particle physics, should be everywhere, but none have ever been found. 3 impossible clues. 3 hints pointing to something beyond our universe. And then, in 1981, theoretical physicist Alan Guth proposed a bold solution: cosmic inflation, an explosive, faster-than-light expansion in the first trillionth of a second after the Big Bang. Inflation stretched space so quickly it explained everything: the uniform temperature, the flatness, the missing monopoles. But inflation had a side effect Guth and others couldn't ignore. It shouldn't end everywhere at once. Some regions of space, far beyond anything we can see, should still be inflating today. Forever inflating. Creating cosmic bubbles, each containing its own universe with its own laws of physics. Our universe is one bubble, surrounded by countless others. Inflation didn't just solve problems. It opened the door to the multiverse. If this idea were purely theoretical, it might be dismissed as fantasy. But then came the evidence. Real, observable anomalies, right there in the sky, in the oldest light we can measure. The first clue, the cosmic microwave background cold spot. When NASA's WMAP and later ESA's Planck spacecraft mapped the leftover radiation from the Big Bang, they found a massive circular region far colder than the surrounding space. Too large to be explained by standard physics. One hypothesis: our bubble universe once collided with another. The cold spot is the bruise. Then, strange polarization patterns appeared in the microwave background, faint twists in ancient light. These patterns, called B-modes, could be the signature of primordial gravitational waves, ripples in space-time generated by inflation itself. Subtle, delicate, but incredibly telling. Next came the phenomenon known as dark flow. Across billions of light-years, galaxy clusters appear to be drifting in the same direction, as if pulled by a gravitational force beyond our observable universe. NASA's observations revealed a coherent motion of hundreds of kilometers per second. What's pulling them? Not anything inside our universe. Perhaps something outside. And then came research teams at Oxford, at MIT, at the Perimeter Institute, analyzing CMB data looking for specific circular patterns predicted by inflationary collisions. And they found them. Not conclusively. But not randomly either. The cosmic puzzle pieces were forming a picture far stranger than anyone expected. But the next set of clues came from the quantum world, from the realm of the very small. In the 1950s, Hugh Everett proposed the many-worlds interpretation of quantum mechanics. Every time a particle is observed, reality splits. Every quantum probability becomes its own world. Every decision branches into a new timeline. At first, this sounded philosophical. Today, experiments in quantum coherence and computation show that Everett's prediction describes quantum behavior far more naturally than the alternatives. Reality might not collapse, it might expand. Infinitely. Then came the mystery of the cosmological constant. The vacuum energy of our universe is incredibly, absurdly small, orders of magnitude smaller than theory predicts. Too small to be random. Too small to be explained. Unless, we live in one of many universes with different vacuum energies, and only universes like ours can form galaxies. Finally, string theory proposed something almost unbelievable, a landscape of 10 possible universes. Different laws, different constants, different geometries. An unimaginable cosmic diversity. Universes not as exceptions, but as the rule. Some physicists, like Lee Smolin, went further. He proposed that black holes might spawn new universes. That every black hole could be a doorway. That our universe could be the child of another, formed in a cosmic lineage stretching back into eternity. Piece by piece, evidence from cosmology, quantum mechanics, and theoretical physics converged on one conclusion: reality is bigger than everything we call the universe. Now, zoom out. Imagine the totality of existence. Not one universe expanding in empty space, but endless universes, bubbling, branching, colliding, evolving. Eternal inflation paints a picture of a ceaseless, ever-growing cosmic ocean, with universes forming like foam on a wave. Each bubble expanding internally, each with its own beginning, its own physics, its own fate. Many worlds suggests that even within a single bubble universe, reality is fracturing into infinite timelines at every moment. Not spatially separate, but layered, like overlapping sheets of possibility. String theory adds extra dimensions, vast, invisible spaces beyond our three-dimensional experience. Universes may be like membranes floating in higher dimensional space. Sometimes these membranes collide, triggering big bangs. Ours may have begun exactly this way. Together, these frameworks describe a cosmos not as a single entity, but as a multiverse. A grand, infinite structure where universes are born, live, and die like stars. The possibilities are staggering. And we may soon test them. In the coming years, the greatest scientific instruments ever built will turn their eyes to the beginning of time. The Simons Observatory. The CMB ESFA project. The James Webb Space Telescope. The Roman Telescope. LISA, the space-based gravitational wave detector. Each designed to probe deeper into the cosmic background, the early universe, and the structure of space-time itself. They may detect new collisions, new anisotropies, new gravitational signals, patterns that simply cannot exist in a single universe model. On the quantum front, advances in quantum computers may reveal branching patterns predicted by many worlds. Simulations could map the landscape of possible vacuum energies. AI-assisted cosmology might uncover subtle fingerprints no human could detect. We stand at the edge of a revolution in understanding. But beyond the science, there is something more profound. What does it mean for us? If the multiverse is real, then our universe is not the default. Not privileged. Not central. It's one possibility among countless others. Other universes may have different chemistry. No atoms. No stars. No time as we understand it. Others could be mature, ancient, impossibly complex. Some may host life, alien, incomprehensible, thriving on physics we can barely imagine. And what about universes connected to ours through quantum branching? Universes where history played out differently? Where a different version of you made a different choice, and that divergence spread through a new timeline? The multiverse does not diminish us. It expands what it means to exist. We are not alone in the cosmos. We are not even alone in reality. And yet, despite all the theories, the data, the predictions, certainty remains elusive. Physics hasn't reached its final chapter. Observations still evolve. Models still compete. The truth might be far stranger than even the multiverse. Or far simpler. But the evidence grows. And the questions deepen. From a cold spot in the sky, to galaxies drifting toward an unseen force, to the quantum shadows of parallel outcomes, to the possibility that our universe itself was born from another. Everything points to one extraordinary possibility: the universe is not a universe at all. It is one chapter in an infinite library. One island in a boundless ocean. One page in a story without end. And as our instruments sharpen, our models improve, and our curiosity intensifies, we may soon be the first species in history to confirm that reality is far larger than we ever imagined. The mystery endures. The search continues. And the journey has only just begun. The universe is vast. The mysteries are endless. The journey continues. Thank you for watching. If you enjoyed this, please like and subscribe for more stories each week.